Hello wonderful person, this is Anton, and today we're going to be talking about a pretty incredible discovery that suggests these incredible, large, massive structures in the universe that form the cosmic web seem to actually be spinning and producing the so-called angular momentum that might give other objects, such as galaxies, the angular momentum needed to spin as well. But let's discuss this in a little bit more detail because this is a pretty complex topic. First of all, let's establish the scale here just so that you understand how big of an object we're talking about. Once we start moving out of our solar system, we'll first find ourselves in a local cluster of nearby stars. And eventually this will obviously produce our galaxy. And pretty much all of the objects at these scales have some sort of an angular momentum somewhere. Now obviously all of the planets and all of the smaller objects in the solar system spin, also the planets themselves orbit around the sun, which is also a result of angular momentum, but even if you zoom out and look at further stars, even in various nebula or in various globular clusters, things have a tendency to spin as well. And all of this also spins around the galaxy. So this angular momentum seems to be present all the way to the galactic sizes. But what if we zoom out a little bit more? Well, first of all, we'll find ourselves in the galactic cluster. And here the galaxies do have a tendency to orbit around one another as well. And this of course means that the spin and the angular momentum is still available and still visible even at the million light year scale. However, once we zoom out far enough, specifically here it's about 100 million light years, and start looking at larger clusters, here we're talking about what's known as a supercluster, and this one being the Virgo supercluster and the even larger cluster known as Laniakea. Well, at this point, so far no spin has ever been detected. But do things also spin on larger scales as well? And that's of course one of the major questions that the scientists are trying to answer. Although, quick side note, what exactly creates this angular momentum and what exactly creates this spin? Well, on smaller scales, it seems to always happen when two objects that somehow can interact with one another, so for example through gravity, somehow pass close to each other and start interacting, thus creating the spin that you see right here that eventually starts developing into a more complex angular momentum. Now this is what happens with a lot of star formation, this also happens with a lot of galactic formation, and we also see this in liquids and in gas, for example, so it does happen pretty much everywhere. Although the actual nature of this and also the actual explanations are still not really well understood. But in the last few years, the scientists also started to discover some unusual observations from various galaxies and especially various quasars out there. They started to discover some unusual patterns suggesting that certain galaxies were sort of spinning in the same direction or in the same way. I've talked about one such study a few years ago, and it essentially discovered that there were quasars along the formation known as the cosmic web that seemed to have rotation in the same direction, as if something provided the angular momentum to them, because if this was by chance, they should all be pointing in completely random directions. And this sort of implied that something else is going on these larger scales, something that seems to be guiding the overall spin of things in the universe. And so naturally it's kind of interesting to figure out if something else is going on these large scales, with something else giving the galaxies their spin. Although interestingly, a lot of these simulations that the scientists performed over the years, with the biggest one being the Illustris project, to some extent also have been suggesting a major spin going on in these larger structures. Now, which structures are we talking about? Well, we're really talking about these cosmic tendrils or cosmic web that you see right here. It's not really visible in this picture, but it sort of goes all the way here, connecting all of these galaxies together and forming this really massive formation that's been detected over and over again in various studies. For the most part, it seems to be made out of the mysterious dark matter, but it also contains a lot of different gas, some of it actually primordial gas, that has never been anything but gas. It never formed any stars, it never participated in any formation of anything, and it sort of stayed as gas for the past 13.7 billion years. A lot of this gas will never actually become anything. But some of this gas gets funneled into various galaxies and is responsible for making the galaxies around the universe become larger and larger, and also growing the black holes in the middle as well. So all of this is to some extent guided by the cosmic web. And although it's still difficult to imagine what goes on inside the cosmic web, some scientists speculated that it's sort of like these tunnels of diffuse gas, where the gas slowly is funneled into various regions around the universe, forming certain globular clusters and forming various galaxies. But the galaxies themselves also stay inside the cosmic web as well. They actually seem to be moving inside of the cosmic web, and they also seem to be spinning along the axis of the web itself. At least that's what the scientists thought, and this is what the simulations showed us. And now it looks like we do have a confirmational proof, and a somewhat unexpected observational proof, that the cosmic web indeed spins, and very likely provides a lot of the angular momentum to a lot of the structures located inside the web. And that's of course being galaxies, clusters, and superclusters that are most likely aligned along the web as well. This of course implies that even the clusters here are probably moving in a somewhat circular motion, although it would be very difficult to detect this because of the actual sizes involved. And naturally also because all of this takes a really long time. But what exactly was detected right now, and more importantly, how was it detected and how accurate are the observations? Well, the data itself came from the very famous Sloan Digital Sky Survey, with the data containing thousands and actually hundreds of thousands of galaxies. And because the structures the scientists were trying to study were extremely large in size, they essentially had to divide the night skies into tinier chunks. They separated each of the filaments into different segments and turned each of the segments into a kind of a cylinder, with the galaxies here being approximated as either being located on the part of the cylinder that moves away or the part that moves toward us. And then by carefully observing the redshift of each of these galaxies and averaging the observations depending on the location, they were able to definitively see that certain galaxies were approaching us on average at a speed of about 100 km per second, whereas other ones were moving away from us at around 100 km per second. And this was of course depending on the location inside this cylinder-like formation created by the galactic web. This image right here being a pretty good visualization of the kind of a cylinder I'm talking about here. So some parts will be receding, other parts will be coming toward us. But because these structures are so humongous in size, here we're talking about hundreds of millions of light years long, and maybe a couple of million light years across, it was relatively difficult to do these observations, but naturally, because of the total number of galaxies used and because of the observations of different parts of the night sky, the average calculations indeed showed that the spin seems to be there. The galaxies were definitely moving away on average or coming toward us on average. Although at the moment, there is unfortunately no good explanation for how it's possible. Now, we do believe that overall the spin itself usually forms when there is some sort of a higher density versus smaller density of stuff. So in the universe, that's probably why certain galaxies acquired spin. But in these larger structures, it's very difficult to explain the overall spin of a tendril or a galactic web, especially because the scientists today believe that on average, larger objects in the universe should not have any spin or any kind of a curl. There's really no reason for any kind of a rotation in the early universe, at least from the models we have about the early universe. Which of course means that our models right now are very likely not entirely correct. Something out there definitely seemed to have created the spin for at least some of these cosmic tendrils. And since other studies doing other observations have also observed a kind of a common spin to different objects that are really far away from each other, overall all of this sort of starts to make sense. It just doesn't have a really good explanation yet and does not help us understand the early universe based on our current understanding of the cosmological events. And this would also of course explain how galaxies are able to spin in the same direction. It would also explain how dark matter seems to move around and how the halos in those galaxies move as well, while also helping us explain some of the other unusual observations of various types of motion across the universe, and possibly even helping us resolve certain other mysteries. Maybe this will help us explain the unusual observations of the so-called Hubble tension, although for now it's all kind of early to tell. What is really exciting though is that this is the first confirmation and the first official observation of the actual angular momentum and the actual spin of the largest structures we've seen so far. Here we're talking about hundreds of millions of light years big, which is of course like 1,000 times bigger than the entire Milky Way galaxy. But there were of course other discoveries from this study as well. For example, the actual speed of the rotation depended on the angle from which we were looking at the cosmic web, with the highest velocity detected when we were looking at this completely edge on, while at the same time the highest speed of the rotation was usually very close to massive halos of extremely massive galaxies where we expect to have a lot of dark matter as well. And the more massive the halo, the faster the rotation detected. So definitely quite a lot of interesting discoveries. Although for now, that's really all we know. Once the scientists find out something else about this, or once we discover some other unusual object spinning somewhere out there, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining the channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.